So my presentation, DevAssistant, Docker, and you, it's mostly going to be about Docker and about my thoughts about Docker and why I think Docker is so successful and why it's revolutionizing the IT industry. And the second part is going to be about DevAssistant, which is a tool that I work on and which is supposed to make developers' lives easier by automating some tedious tasks. And because I'm from the Czech Republic, I'm also going to talk about beer in the third part of this presentation. Because this is what we Czechs do. We talk about beer. So let's talk about Docker first. So to understand why Docker is so successful, we must know the answer to these two questions. So what is Docker, or more generally containerization, and how is it different from virtualization? Let me just ask you, how many of you know answer to these two questions? Okay, cool. So I think it's best explained with an image. So I have two images here. The one to the left displays how applications work when using containerization, or more specifically Docker. And the image on the right explains how virtualization works. Now, let's start with virtualization. So with virtualization, you basically have your server, which is like a physical piece of hardware running somewhere, and that server is running a host operating system. So let's say it's a Linux. And on that operating system is a special piece of software that is called hypervisor. And this is the thing that basically creates a virtual machine, so emulates physical hardware for the guest OS. And guest OS basically is a full-blown operating system running inside a virtual machine. And inside this guest OS, you can run an application. So this is how it looks. And basically, if you think about it, if your application needs to do some system calls and to do something with the underlying hardware, all the calls basically needs to go from the application to the guest OS and then through hypervisor to the host OS and then to the physical server. Now, there are some technologies that can allow virtual machines to skip some of these steps, but generally this introduces a pretty big overhead, right? And another thing why virtualization can be pretty slow is that if you want to run multiple applications in isolation, so every application in a separate virtual machine on the same server, you basically need to run an operating systems, right? So every application has a full-blown guest operating system. And so if you're running two applications, you are basically running three operating systems with all the system services and everything that's connected to that. And if you're running 10 applications, your CPU is probably going to crawl out of your server and is going to kill you because it's under a huge strain. So while this is good and introduces a good level of isolation, and you can even run like an arbitrary operating system in the virtual machine, like you can run Windows guest OS inside a Linux host OS, it's pretty heavyweight. It introduces a lot of overhead. So let's have a look at containerization, which takes kind of a different approach. So with virtualization, again, you have server, which is the physical piece of hardware, and you have host OS. And on top of it, this image actually shows Docker Engine, but Docker Engine is not actually running while your applications are running. The way it works is that when you want to start a Docker container, basically Docker creates a new file system for the container and runs a single process that is your application, say application B, with that new file system as its root file system. And basically that application is using binaries and libraries inside that root file system, but it doesn't have a guest operating system. It uses the kernel of your host operating system. So basically, an application that is containerized has pretty much native performance, right? So this is the first advantage when compared to virtualization. And the second advantage is that there is no guest OS. So if you're running 10 applications, then you're basically running 10 processes. And so you have pretty much native performance even with multiple containers. So this is one of the key parts of Docker's success. Now, when we are talking about Docker, there are three key terms that we must understand: Docker file, image, and container. And when I was preparing for this presentation, I was kind of struggling, thinking about how I can explain them. And then I think I found a beautiful analogy. So you can think of Docker file, image, and container as of makefile, a binary, and a process. So makefile, as we all know, is basically a file that describes how to build your source code, right? And so when you execute a makefile, you get a binary out of it, something you can run, or it's a library that can be linked. In the same way, Dockerfile is a file that specifies how to build your image. And image is some sort of binary set of bytes that's stored somewhere on your computer. And going back to the first analogy, to the makefile, binary, and process, if you execute binary, you get a running process. In the same way, if you run an image, you get a container, and container is just a process. And this analogy goes even further, because you can run binary to get multiple processes if you run it multiple times. And in the same way, you can run an image multiple times to get multiple containers, and they don't touch the image itself. Now, to illustrate that on an image, let's say you start building an image that is based on Debian. I would really recommend using some Red Hat branded distro like Fedora or Red Hat Enterprise Linux, but unfortunately I only found picture with Debian, so okay. So this is what your Docker file may look like, and it can really be this simple. So the first line from Debian basically says that Docker should use Debian base image. Now, the base image is basically the smallest thing that you can run as a container. It's the smallest set of libraries and binaries that can be used as a container. And it's usually distributed or created by the distro. So Debian people will create Debian images, Fedora people and Red Hat people will create much better Fedora images and stuff like that. Now, so this is the first line. The second line, run apt-get install Emacs, is, so apt-get install Emacs is how you install Emacs in Debian and Ubuntu and other similar distros. So what this does is that when you run docker build, is that Docker takes the context, which is basically Debian. So on this image is this lowest box. And in that context, it runs apt-get install Emacs. And what that does is that it creates a layer on top of the Debian base image and installs Emacs into that layer and leaves the Debian base image alone, untouched. So now we basically have two layers, the Debian base layer and the Emacs layer, which only contains files and directories that changed or were added or maybe removed. And we do the same with Apache. So we get a third layer. And since this Docker file is so short, Docker build basically, as a result, gives us reference to this @Apache image. And so when we want to run that as a container, we use docker run, the reference to the Apache image, and some command. So like user has been httpd, which is the command that runs Apache web server. Now what this does is that Docker takes all these layers and basically squashes them into one and puts them somewhere into your file system, into a directory, and runs the given command with that directory as the root file system. So it's this simple. It's really super simple, and I think this is the huge part of the Docker success. Because Linux containers have been around for some time, but this thing with building images and like images basically inheriting from each other while not modifying themselves, this is really cool and really clever. And so if you want to, you can run like 10 containers from this Apache image, and the images basically stay unchanged on the file system. Is this clear? Do you have like any questions for this? Okay, cool. Now, again, when I was preparing this presentation, I was trying to kind of think in general where application development is going. And I remembered one of my university lectures. I got kind of nostalgic by then, but okay. And so I remembered a lecture about operating systems and how they developed over time. So when operating systems started, they were just huge monolithic blobs, right? It was just a huge blob of code that had no internal structure. There were no internal APIs, and everything was using everything. And if something broke, you didn't want to be around because no one could really debug that. It was like 1950s, maybe 1960s kind of operating systems. So then, obviously, people who were writing operating systems thought, well, this is not really the right way to do it because we can't debug it, we can't extend it, it's just insane. So they started creating what is called layered operating systems. And what a layered operating system is that basically there is a core and it has multiple layers on top of it. So there are layers, for example, to control memory management and input-output operations and stuff like that. And so the layers have certain type of APIs and they communicate with each other and they just, every layer has a task. So there's like there is an inner structure and it's all just sorted out. But it was just not enough because operating systems grew more and more and they were more complex and so they needed something better. So that's how modular operating systems were formed, and now I'm talking about the modern Linux and modern Windows and I guess Mac OS too, but who uses that? So these operating systems have very minimal kernel core, and basically they have set of modules that can be like maybe taken out and replaced by another module that offers the same API, and they can be extended by adding more modules and stuff like that. Now if you think where application development is going, can you read that? Okay, cool. So if you think where application development is going, it's really pretty much the same, but it's falling behind like 20 or 30 years. So like maybe even in 1990s and earlier, we had these applications with tight coupling. Basically, again, application was monolithic. It was a huge blob. Everything depended on everything else. It wasn't really debuggable and stuff like that. So around year 2000, the SOA concept emerged. SOA stands for Service-Oriented Architecture. And this is the architecture where you have like looser coupling of components. So you have a couple of bigger components that are talking to each other through APIs, maybe through a message bus or something like that. And it all works. But again, this is something kind of like the layered operating systems. It's better than monolithical, but it's not good enough. What we really want is microservices. And microservices is kind of concept where you break your application into the smaller pieces you can, and you run these pieces separately, and they communicate through each other. And when you think that this piece has like poor functionality or it's too buggy, then you can just throw it out and you can put there another piece that has the same API, but it's much better, it's faster, it's more stable, or something like that. So this is really what we want. And if you think about it, Docker is ideal for this. Because if you wanted to run a microservice application using virtual machines, again, your CPU would crawl out of your server and kill you, because you would run so many virtual machines that it would just be unbearable, right? So Docker is so much better for this because it has pretty much no overhead. And so this is now the way in which applications are developing, and they will be going that way. I'm not saying it's for all applications ever, but for like 80 or 90% let's say, web applications that run in clouds and have databases and use caching layers and something like that, this is really the way to go. And Docker is good with that. So let's just go through some more advantages of Docker. So I've already said that basically Docker is great for speed because it introduces no overhead and pretty much processes run natively. Docker is great for development. And this is the reason that Docker is great for development is that you can basically run your application in a production-like setting on your development laptop without a huge overhead. And basically, it is just about building some Docker files. It doesn't touch your operating system at all, so nothing is broken. And you just build some images, and then you run them as containers. And you're just basically coding live inside the production setting, which prevents all different sorts of bugs that are hard to debug and you don't want to hit them. Docker is great for dependency management. And the reason for that is that basically you can take every service that makes up your application and you can put it into a separate image and you can manage its dependencies separately. So you can be sure that this image is running precisely with these dependencies and that service is running with that dependencies, and you have that all sorted out. Portability. Docker is great. I get a feeling that I'm repeating that a lot. Okay, Docker is great for portability because you can basically take an image for Docker and run it on any Linux system and it will just work, right? It just requires a core of version, I don't know, 3 point something, and if the Linux system has that, any Docker image will just run on that without problems, without any bugs, and something like that. Component reuse. The Docker folks have come up with what they call a Docker Hub or a Docker registry, which is kind of a centralized system for sharing Docker images. And the way it works is that, for example, the way I would hope it works is that, let's say there are developers of a popular database, so PostgreSQL, for example. And so these people who develop the PostgreSQL database itself create a Docker image and put PostgreSQL inside it and put some good settings and maybe debug it and something like that, stabilize it and put it on the Docker Hub. And other people start downloading that and using that inside of their infrastructure. And these people maybe find some bugs and report them back to the PostgreSQL upstream, to the PostgreSQL creators, and they fix them. And so by iterations, because everyone is now using the PostgreSQL image, and it's the single build that can be deployed anywhere, so no one is doing like their private builds of PostgreSQL, building it for I don't know what. So everyone is using the same build, and so through this, and basically through the community forming around this image, the image gets stable and hard rock solid. Okay, rock solid or hard. Let's just forget I ever said that. Anyway, so this is component reuse. Again, this is a great feature of Docker because I really think that in future people will start using like the official images shipped by the creators of various services, and so through these services will become really stable for everyone. Now about security. Containers are not security, okay? They are not. And people may tell you that containers are secure, and they are lying to you. Containers are not security. You can secure containers with additional technologies, like SE Linux, for example. But containers on their own are basically just change roots, and there is a pretty easy way how someone can write a program that will escape the container when you run it and do something wrong with your system. So don't just trust images from anyone, because they can really be harmful. Or you can run them with SE Linux. You just need to be aware that containers are not secure by default and that you need to put additional security around them. And one of the things that I think is maybe most important about Docker is that it has a friendly face. If you go to Docker upstream documentation and start reading through this and start doing the tutorial, you can understand the thing in like 2 or 3 hours. And I don't know if you've tried Linux containers before Docker came, but it's really hard, and it's really, I couldn't understand it myself, and I was digging into that I don't know how long. And it was not done this easy, never before, right? So friendly face is one of the biggest advantages of Docker. So this is how I looked when I started experimenting with Docker, and after 2 or 3 hours I figured out how cool actually it is. So development with Docker is super easy, right? Well, if the answer to this question was yes, I wouldn't be standing here. Just because Docker encourages better infrastructure and better deployment and better practices doesn't necessarily mean it's easier to develop with. And if you think about it, if you're starting a new project, there's always tons of things that you need to do before you can actually start writing your code. I tried putting some of these things on one slide, and this is how it turned out. It's just too many things that you need to do before you actually start writing your code. To read out some of them for you, you need to kickstart your project source code, you need to find out what dependencies you will need and how to install them, you need to create Docker files, you need to build your images, blah, 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 blah. You don't want to do that, right? You just want to do this. Or at least I hope so, right? You want to do that, right? Okay. So this is why me and some folks that I know started working on DevAssistant. This is DevAssistant logo. And so the idea is that instead of doing these things that you don't really want to do, you just run a tool that does them for you and does that in 2 or 3 minutes, maybe, and then you just write your code. Wouldn't that be awesome? I don't know, would it? I thought so, but maybe not. Okay. So, second part is about DevAssistant. How much time have I got left? 10 minutes? Yeah, okay. So anyway, DevAssistant is a tool to satisfy all developers' needs except brewing coffee. We can't brew coffee yet. But if someone wants to send us a patch, we will accept it. So what can DevAssistant do? DevAssistant itself is basically just a core or framework that executes plugins. And plugins can do pretty much anything. They can install dependencies, or they can create GitHub repositories automatically. They can scaffold new projects. They can set up your environment. They can, say, build Docker images or run Docker containers and link them together properly. And just, variety of stuff, pretty much anything you can think of. It's really highly pluggable. And it can do anything, assuming someone actually writes the plugin that does that. So, we try to write a lot of plugins, but it's really time-consuming. So my current objective is to provide means to easily kickstart and work with container-based production-ready environment. Now, it actually took me a good part of an hour to write this sentence. And I think it's really great sentence. And when I'm done developing, I will go to marketing department. So anyway, but this is really what we want to do, right? So the idea is basically that you run run a command that creates your project, and it generates like some basic source code, and it generates the Docker files, and does everything for that. And then you perhaps run a second command that just builds the images, starts the containers, and does everything that you need to do, so you can just wait for 2 minutes and then just start writing your code instead of doing random stuff for 2 days and banging your head against wall or something. Demo, I'm actually running really short on time, but I've heard there's like a pub crawl after the conference, so I may actually show you the demo there if you're interested, so just feel free to come to me and I will show it to you there, because I really want to talk about beer. So it's really great, because when I walked from my hotel up to this venue, I think it was like 1 kilometer, and I saw like 4 or 5 advertisements for Czech beer, which is great. I really love Budapest, guys. Thank you. So anyway, what is this about? Like two or 3 months ago, I started what I call the DevAssistant 100 GitHub Stars Beer Competition. How it works? So GitHub is the hosting service that has, these stars. So basically, if you like a project, you star it, so you are kind of watching it or something, and then it measures the popularity of projects. So I decided that for everyone who will help DevAssistant get better, I will buy a beer if we ever meet or something. If you want to get a free beer from me, you can just follow the instructions at this URL. I don't really have the time to go through all the instructions right now, but please do. I mean, if I would certainly love 1,000 new contributors to DevAssistant, but it would probably ruin me. So just, be cautious about that, because if I'm ruined, I won't buy anyone another beer. Yep. So this is the end, and I will accept your questions.